Hey guys, it's Miss Kaiser, coming to you from my living room. Um, so I know a lot of people have had questions about how to do the Unit 10 review number 2 that I sent out, which, I mean, this is a paper copy, but um, obviously not everyone has printers to do a paper copy, so you can do it online, you can do it in any kind of um, computer format you can, or if you can, work the problems out on paper and just take pictures of them and send them to me. Basically, anything is going to work at this point in time. But I kind of wanted to go through it with you guys and explain some things and maybe kind of show you some tools that I found that may be helpful just to help you out as best I can and get you ready to take this test. So hopefully this helps. And if you have any other questions, that have to deal with these problems, just let me know. And well, this is the first time he's come in front of the camera. So this is my dog Bogey. Say hi, Bogue. You gotta look up there. You gotta look up there. Say hi, Bogue. Yeah. Okay. All right. So we're gonna get started. So let me show you my screen so you can see what I'm doing as we go through this. Okay. So hopefully everyone can see my screen now. So I'm going to pull up the document, just like a document form of the test review, just so you can see the problems and see what we're going to be talking about and going over. So for this Unit 10 test review number 2, the very first two problems are graphing piecewise functions. So we'll go over 2 of those examples. The next 2 problems are graphing a system of equations. So there's 2 systems we have to graph, and remember with systems there should always be answers involved, so we'll talk about what the answers will be. And then there are 2 examples of graphs, such that if you're given the graph, can you find this information? So like domain range, positive, negative, increasing, decreasing, maximums, all that jazz. So we're going to start at the very top with graphing the piecewise functions. So, a lot of you have noticed that if you want to graph a function, it's not going to go very well if you're using Word or if you're using Google Docs. So, what I have found, or what I have thought of that you could possibly do, is that Google offers a Google Draw. And so basically, it's kind of like a paint version of Google, and you can create different things in that. So, this is what it'll look like. So if you were to go to Google Draw, you could find just a blank 10 by 10 coordinate plane. Like you can Google that and copy that picture into your Google Draw. Or I have this one that I sent out to you guys. So all you have to do is take a look at this. Now, you don't want to edit anything on this one because this is my copy. It's the blank copy for everyone to use. So what you would want to do instead is you're going to make a copy of this. So you're going to go to File, you're going to make a copy, and this will go into your Google Drive. The name of it, whatever you want the name to be, if you want to use maybe your last name or whatever problem number you're working on, something along those lines. But whatever you want to call it, you can call it. So let's say this was just Kaiser problem number 1 because it's number 1 of the test review. So I'm going to make a copy of that, and it should automatically open that copy for you. Okay. So here is the copy of the coordinate grid, and now I can manipulate this and do whatever kind of drawing I need to do on this. So one thing I am going to do, and this will be a little bit different, you guys don't have to do this, but I am going to copy the equation or the piecewise function over here just so it's all on the same screen. So this I'm going to use my snipping tool for. So if you've ever used snipping tool, it's kind of like a capture feature on your computer, and you can capture different parts of your screen. So I'm going to create a new snip. I'm going to copy this function, and then this little button does a copy, and I should be able to paste it over here. And there we go. So there is a copy of our function so we know what we're working on and where things should go. So for our piecewise functions, remember that the very, very, very first thing that you're supposed to do is create a boundary line. So we look at these little if statements at the end of our problem, and that's going to tell us where our boundary line is. So remember, whatever this number is, that's where a vertical line is going to go. So since this is 3, I'm going to find where x equals 3 on my coordinate plane. And remember, I'm going to draw a vertical line in that spot. Now, for my lines, if I go over here to my line tools, there's a couple different options that you have for your lines. For this one, so they don't do arrows on both ends, or at least maybe they do. I'll figure that out later. But we at least need a line to create our vertical line. So if I go over to where x equals 3, I can go straight up. And what I'm actually going to do is I'm just going to manipulate that line that I already drew. So I'm going to click on the select tool so I can drag it down to the very bottom of my graph. Okay, so now it extends all the way through. And then there's a couple other little options I can do with it. I can make this line a different color. So I'll make it red. So remember, it's a boundary line. We don't want to cross this boundary line. So I'll make it bright red. I can make it a little bit thicker. So like this makes things thicker. And then remember, this is always supposed to be a dashed line. So I'm going to go ahead and choose the dashed version of this just so that I make it a little more accurate for us. And then, oh, okay. So here's options for our endpoints. So remember, lines continue forever and ever. So I'm going to choose one of these arrows. I like this top one a little bit more. So I'm going to make an arrow bottom there, and then same thing on the other end, an arrow up there. Okay, so now we can see our boundary line. It is dashed, it is red, it has arrows at the end, it's where it's supposed to be. Okay, all right, so the next step after we create that boundary line, remember a piecewise function, we're trying to separate these two functions out. So one function goes on one side of the line and the other function goes on the other side, and they're not supposed to cross each other, right? Like it's kind of like enemy territory. One can only exist on either side. So how I determine which function goes where is I read these little if statements. Okay, so for this top function, it says if x is less than 3. So if x is less than 3, all the numbers on the left side of the line are less than 3, like all these negatives over here. So that's where the top function is going to go. It's going to go over here on the left. So let me see if I can make a little note of that. Okay, so this is, I can't type the function in. It won't really let me type functions, but I'm going to say this is the top function over here on the left, which means, and you can kind of verify this if you read it, if x is greater than or equal to 3, that's going to be over here on the right, because this is where all the numbers are bigger than 3. So I'm going to draw another little text box right here, just saying that this is going to be the bottom function. Something else we're also going to need to know, or going to make a note of, is remember when you hit the boundary line, these little symbols also tell us if we're going to put an open point or a closed point. So for this bottom one, since it has a line underneath it, it would be a closed point. So I'm going to go ahead and make that in this little text box, closed point, just so I have a note of that. And then, sorry. So for this top function, since it has no line underneath it, it's going to have an open point. So I'm going to make a little note of that, just so that is kind of nicely labeled out for me. Okay, so basically, after we get our boundary line, after we decide which function goes where, and what kind of points they're going to get, now I have to actually go in and graph these functions. So I don't know how much of this I'll be able to take note of, but just kind of bear with me. This x minus 2 squared, this is our top function. That's going to be on the left side of my grid. this function, so remember, you always want to ask yourself what type of function it is. So you're looking for symbols or clues that might tell you what it is. So if I look on the outside of the parentheses and I see that square, that exponent 2, that's going to tell me this is a quadratic. Okay, so quadratics are parabolas. Okay, remember, those are ones that you have to actually know the name of it. It's a parabola. Um, and typically, our parabolas start at 0, 0, and they would have points at 1, 1, 2, 4, and 3, 9. And then same on the other side, negative 1, 1, negative 2, 4, negative 3, 9. However, this is not a normal parabola, right? It's not just x squared. It's x minus 2 squared. So for this minus 2, because it's on the inside of my parentheses, remember inside numbers are left and right movements, so it's transforming, it's shifting either left or right, and if it's a minus 2, that means it's going to shift to the right 2. Okay, so maybe I'm going to make a couple little notes here. So our top function, it is a parabola. It starts at 0, 0. It is shifting right 2. Okay, so every single point that would be on your basic parabola is going to shift right 2. Okay, so now how I'm going to graph that, actually let's color code this. Let's make the parabola blue. So let's see here. Oh, that's color. Let's make it blue. And now I'm going to graph my points. So since a lot of these graphs, we did have some basic points before we connected them. For a point, I'm just going to choose a circle shape. So if I go to the shapes, I can do, well, oval or circle. I can take this, put it over the 0, 0, and make this little circle point. I'm also going to change the color real quick just so it matches. It is dark blue to match. And just so you guys see it, so there's my little point at 0, 0. That would be the beginning of my parabola. Okay, so technically, remember, this is not actually starting at 0, 0. We have to shift this right too. So I'm going to pick this point up. I'm going to move it left over to the negative 2. Oh, no, sorry. Shift right 2. I'm going to move it over to the positive 2, silly me. And then I'll be able to graph the rest of my points. So I'm going to pick this up. I'm going to move it over to positive 2 and drop it, click off of it, and that's where it's set. So 2, 0 is going to be my starting point. Okay. Any other points that would go on the parabola, remember, they would just shift over to the right 2. So to create some more points, though, what I'm going to do is just take this little circle that I already have, and I'm going to copy it. So if you hit Control C, that should copy that point for you, or you can go over here to File, or no, sorry, go to Edit. Go to Edit, Copy, it'll copy that little point. So then I can paste it somewhere, so it showed up slightly over to the side, and I want to graph my next point. So if one of my points would be at negative 1, 1, okay, so it would be over here, but I don't want to keep it there. I'm going to shift it to the right 2, and positive 1, 1 is where it's going to end up. So see, here's my 0, 0. Here's my second point. From there, another point would be at negative 2, 4. So I'm going to paste another little point. Instead of going to negative 2, 4, I'm going to shift it right 2. It's going to end up at 0, 4. Okay, and then I'm going to put one more point because there'd be another point here at negative 3, 9. So paste another little point. We're going to pick it up and drag it. So it's at negative 3, 9, shift it right 2. It should end up at negative 1, 9. Okay, so there is the left side of my parabola. Okay, now here's the thing. There would also be a right side of the parabola. But remember, we have this little boundary line over here. Once we hit that boundary line, we can't go past it. So the only point I'm going to be able to plot, if I had a point at 1, 1 and I shifted it right 2, it would be on my boundary line. So I'm going to paste another little point. I'm going to pick it up and drag it. But this one, since it hits the boundary line, okay, remember we made a little note up here saying what kind of point we're going to have, and this one says an open point, meaning I don't want it to be filled in blue. I want it to be left open and clear. So this point in particular, if I go over to my fill color or fill options, there should be a way to make it transparent, okay, meaning it would be an open point. So I'm going to select that. And then if I look, see how this point is now open. I do want the outside to be a little bit darker so it's easier for us to see. So I'm going to go to the border color. I'm going to select blue so we know what graph it goes with. And I'm going to make it a little thicker just so we can see it. And there is our blue open point. Okay, and that's as much as the parabola as we can graph. Okay, any other point would end up over here on the right. Remember, that's not its territory. It can't go over here. So that's all we have. Now, these are just points, right? I got to actually connect them to make a parabola. So my next goal, if I go over to these line options and I click down, there is a curve option. So what I can do is if I select this curve option, I'm going to just go through and kind of connect my points with this curve. So I'm going to start at the open point and I'm going to click on it. And then I'm going to go to this 2, 0 point and click on it. I'm going to go to 1, 1, click on it, 0, 4, click on it, and go to -1, 9, click on it, and I'm going to double click so it ends. Okay, so see how that line became kind of a fuzzy blue color. It's now selected. I want to click my select tool so I don't change anything else on it. And then there's my parabola. So I am going to go ahead and change the color. I'm going to make it blue. So the whole line is blue, and we know that's part of the parabola. But once I click off of that, see how they're all connected, and I don't have to worry about it just being a bunch of points. It's actually a parabola now. Okay, so that takes care of the left side function. Now we have to do the same thing with the right side function. So this bottom function, if I go over here, 1/3 x minus 7. So if you notice, there's no exponent, there's no root symbol, there's no absolute value symbol, there's no symbols for this function, which means it's just a straight line, right? Just think y equals mx plus b. So let's make some little notes here. Let's make this over here a little bit better. Okay, so this is for our bottom function. It is a line. And the y-intercept of this line is the -7. So we would start at -7 on the y-axis. And the slope is 1/3. So we want to go up 1, right 3. Okay. Now keep in mind, typically when you start this line, it's going to start on the y-axis on the left-hand side. Remember, we can't actually start there. It's on the wrong side of the graph. So we'll kind of look at how to graph that and get that started. So this color, this particular line, let's see what color do we want this. Let's make it, let's make it green. Okay, so we'll make it this dark green color so we know what part the line is. All right, so for my line, again, I need some points for my line, right? So I'm going to go to shape. I'm going to select the oval, and then we're going to kind of start it like we would at this -7 on the y-axis. Okay, so I'm going to draw this little point right here. For the fill, I'm going to go ahead and fill it solid green because technically that point, we're not going to keep it there, right? We want to move the points over here. So if this line were to start at -7, for the slope, we would have to move up 1 and to the right 3. Well, if I move up 1 and right 3, it hits my boundary line. Okay, this is technically going to be the first point on this line, is the point 3, -6. So I'm going to pick this little point up. I'm going to move it over to 3, -6, and that's where my line's going to start. Okay, so I'm going to continue that up 1 over 3 pattern to make some more points. So I'm going to take this green dot. Remember, you can copy and paste it. So I'm going to copy it, paste it, And then if I move up 1 to the right 3, here's my next point at 6, -5. Looks like I can make one more, so I'm going to paste another point. So from this second one, up 1 to the right 3, paste a new one, and the next one will go off the grid over here, so we're not going to worry about it. All right, so here are the points for my line. I want to connect those, so remember I'm going to go over to the line tool. I don't want it to be a curved line anymore. I want it to be a straight line. I'm going to go to the straight line option. I'm going to start at this point, work my way over, kind of drawing a line in between those. And when I finish that, select tool, I'm going to change the color so it's green so it matches the points. I might make it a little bit thicker just so you guys can see it. And there we go. There's our line. So here is our whole piecewise function. This is how it would look and how it would work together. The parabola exists on the right-hand side up until the boundary line. And then once the boundary line hits, this line would exist from here on out. So this would be our final answer. This is what you would want to copy and paste into your answer box, which you can do that by sharing. So if you choose to share it with me, you can click on this Get Shareable link, and the shareable link will provide this URL for you, so you can just copy it, so you don't even have to worry about Control C. You can just copy the link, and then you go wherever you need to go to paste it. Yeah, so there's one way, or if you like the snip tool, like I showed you, you could make a new snip, and you could, let's make sure the whole graph is visible. You could just drag it over this part of your screen. You can make a new picture, and then that's what you could upload into your answer. So those are two different options for you on how to get this picture in your answer. But that takes care of problem number 1 for us. So I know that's a lot of work. That took a lot of time, but that's kind of the tools that we're working with, just to kind of give you the big idea of what everything's going to look like. Okay. So we have another one of those to practice. So here's what I'm going to do. I'm going to go ahead and make another blank copy of this. Copy. Let's call it problem number 2. Okay, and here we go. So I'm going to pull up my document again just so I know what the problem looks like. So here's our second piecewise function. This is the next one I'm going to graph. I might go through it a little bit quicker, just since I kind of walked you through the first one. But just so you can kind of get an idea of what it's supposed to look like and where things should go. So I'm going to use my snipping tool so I can copy that equation over to my Google Draw. Oh, now I can move this box. Here's my equation. I'm going to copy that. And now we're going to go up here. Okay. So remember, piecewise functions, got to start with my boundary line. This time my boundary line is at x equals 5. So I'm going to create a line. And at the x equals 5, so I'm going to draw a line straight up. And I'm going to use my select tool to just manipulate the one I just drew. So I'm going to drag it down. I'm going to change the color, so it's going to be a red line again, showing it's the boundary line. I'm going to make it dashed, and add some arrows at the end, just so you know it's a line. And then we'll go from there. All right, so there's our boundary. Oh, okay. There we go. All right. Next part, I got to decide what function goes on what side. So when I read this top function, the if statement says if x is less than 5. Okay, well, x is less than 5. Again, that's over here on the left. All these numbers are less than 5. So, Xbox, just to make a note of this, the top function on the right side, and again, it's going to have an open point because the inequality doesn't have a line under it. Okay, and which means that the bottom function is going to go over here on the right. and it's not a close point. Okay. All right. So now to kind of talk about what these functions are and what they're going to look like. This top function, okay, so remember those parallel lines around the x, that is an absolute value symbol. So if that's the function, there are no numbers around that absolute value, so this isn't shifting up and right, or up and down, this isn't shifting left and right, there's no negative in the front, so it's not flipping, it is the plain old absolute value. So remember, absolute value should start at 0, 0, and then it will go up 1 and over 1, and up 1 and left 1, and make a V shape. So that's what we're going for here for this absolute value, is the V shape. So I'm going to make a point with my little circle. I'm going to make it start at 0, 0. And this time, I'm going to make this function orange. Let's make an orange absolute value. And, oh, that was kind of a long oval. Let's see if I can make that a little more circle-like. Okay, well, it's just going to be a little ovalish. So 0, 0 is the first point. I'm going to copy and paste that. And I want another point at 1, 1. So 1. Another one is 0 at 2, 2. And our last one's going to go at 5, 5. But keep in mind, at 5, 5, this is where it's going to hit the boundary line. So I don't necessarily want to remember this one. We want this to be an open point. So when I place it here, before I click off of it, I'm going to go over to these fill options. I'm going to make it transparent. I'm going to make the edge orange, and I'm going to make it a little bit thicker so we can see that it is an open point. So here's our open point that is around our boundary line, and that is the right side of the V shape. So remember, I'm going to make some points over here on the left side. I won't make quite as many, but I will make a few just to give you an idea that it should be a V shape. Go to -1, 1. Let's drag another one to -2, 2. Let's make another one, -3. And from there, you kind of get the idea that this is going to be a V. So I'm going to connect these points. Go over to my line tool. I'm first going to connect my 0, 0 to my open point. Select that, so I can make that an orange line, make it a little bit thicker. So you can see this connected part of the V. I'm going to make another one of those. So go from 0, 0 over here to the left, and I'm just going to change it as best I can to make it V shape. Orange, make it a little thicker so you can see it. Okay, so there is our absolute value graph. It should be a V shape starting at 0, 0, and it connects all the way to the boundary line at 5, 5. All right, so now that one's done. Looking at this bottom function, so again, this bottom function, there's no special symbols around x, there's no roots, there's no exponents, so therefore it's just another straight line. So our y-intercept is going to be this +3, so I'm going to create a point that would end up at +3. This one, let's make this one purple. Purple. Make a little point for it. Now keep in mind, this is on the wrong side of the boundary line. I can't actually keep this point here. But what I'm going to do is I'm going to use it as a starting point in order to use the slope to graph more points. So my slope is -1/2, which means I'm going to go down 1 and right 2 to graph other points. So I'm going to pick this point up I go down 1 and to the right 2, well, that's not to my boundary line yet. So I'm going to go down 1 and right 2 again, which is not to my boundary line yet. So down 1, right 2. Technically, my point's going to end at 6, 0. Okay, so there wasn't a point that ended up on the boundary line. I'm going to have to go back and put one there, just kind of in a close area where it would be. But this is our first real point. It's a 6, 0 point. So I'm going to go ahead and click off of it so it stays there. And what I'm going to do, I'm going to use that to graph the rest of my points. So I'm going to copy and paste another one. And from this one, I'm going to move down 1 and right 2 again. So I end up at 8, -1. And then copy and paste from here, down 1, right 2 again. I should have another point at 10, -2. So those should, okay. So those points should give me enough points for my line. Since this line would technically hit this boundary line, I'm just going to put another point on the boundary line. Remember, this is supposed to be a closed point, so I'm just going to use the plane for the point I've been pasting. Move it there. Okay, so I'm going to pick it up and move it. It's going to end up somewhere in between here. Not going to necessarily be in a perfect spot. Okay, so that's kind of where it would end up. So now I'm going to connect those with a line. So I'm going to start at this point, connect them over, make a line. Let's change this on to purple. Let's make it a little thicker. And there we go. That is our finished piecewise function. So the absolute value is on the left, and the line that is -1/2 x + 3 is over here on the right, and that's where everything should go. All right. So that takes care of both of our piecewise functions. So hopefully that kind of helps a little bit as far as getting them set up and looking at what they should look like and where they should be. Okay. So if I go back to my review, I'm going to go down to problems 3 and 4. So these are systems of equations. Remember, systems of equations, you do want them to overlap. There's no boundary line this time. And we want to pick out the points where they intersect. So that's what we're going to have to be careful about this time, just making sure that our points are in the right spots so we know where they're going to intersect. And just to show you something different, I think what I'm going to try is to show you how you could also do this in Paint. If you're working on a laptop and you have a Paint feature, just to show you another option. So I'm going to grid. Paint app. I'm going to do that. Okay. So in this paint screen, I'm going to paste that grid I just made. So here is here. So here's the grid I'm going to work with. Bigger for you guys to see. And then I'm also going to copy and paste the function again, just so I'm working on the same screen and I don't have to keep flipping forth. So I'm going to snip this third function. Copy it. And now it is also in the same screen with my grid. All right. So in order to graph the system, first I have to think about what these functions are. So if I look at this top function, it is negative absolute value of x plus 4. Okay, so again, these symbols should tell you it's an absolute value function. So I'm going to make some little notes about this. Value, which remember that should look like the V shape. I just did that in orange in the last problem. And there are two transformations happening to this V shape. So if you look in front of the absolute value, there's a negative sign. So that negative sign tells us that our V is going to flip down. Okay, so finish number 1, it's flipping. Transformation number 2. So this +4 that happens after the absolute value sign, that is a shift. Because it is outside, that means it is a up 4, shift up 4. Means most absolute values start at 0, 0. This one's actually going to start at 0, 4. So I'm going to go ahead and start on this graph, just so we can get it done and out of the way. And for this one, let's go ahead and make this one red. So this absolute value is going to be red. Alright, so again, I kind of need some points in order to graph this. So I'm going to make another little oval. Typically, this one would start at 0, 4 or 0, 0. So I'm going to select circle. I'm going to fill it in. With my fill-in color, I want it to be solid red. Select tool again just so I can move it. No, maybe I can't do that. Okay, we're gonna just hit the undo button to get rid of that. Okay, I'm gonna make another little oval. Since we don't want this one to actually start at 0, 0, we want it to shift up 4. So I'm gonna go 1, 2, 3, 4 up to this 4, 0 or 0, 4 point. Sorry, 0, 4. And I'm gonna make my first point here. I want to center this a little bit better. I'm going to have to make the screen bigger. Let's zoom this in a little bit. And this will help me manipulate it a little bit more. So, okay, so here is my point. Granted, it looks a little distorted because I made it bigger so you could see, but here is the 0, 0 point. From this one, I'm going to make some other points. Remember, the V shape is just always up 1 and over 1, but because of this flip, we don't want to go up anymore. We want it to go down. We want it to be like an upside down V. So my next point would go below that. Down 1 and over 1, down 1 and over 1. And you can make more points if you want. Eventually, I'm going to connect these with a straight line. So I'm going to go ahead and make the ones that would be on the left-hand side. So I'm going to go down 1 and left 1, down 1 and left 1, down 1 and left 1, and there would be some points over there. So like I said, you could continue that V for as long as the grid goes. But I think now I'm going to go back and connect these with a straight line. So if I go to my line options, keep in mind I can change the size of this line. I'm going to make it, so if I want to keep it red, I'm going to connect through these points I just made, and I'm going to connect over to the edge, just so I know it does go on forever. Same thing on the other side. I'm going to make another new line, start it at, so I'm going to start this one again at 0, 0, go through my points and connect it over to the edge. Click off for that so it stays, and there is my flipped absolute value that would start at 0, 4. Okay, so that takes care of the top function. Nothing else we have to do there. Let me zoom up a little bit here. Okay, so now for the second function. The second function, again, there's no exponents, there's no groups, there's no absolute value. This is just a straight line. So let's make some notes. This is a line. This one, let's make this blue. So this is going to be a line. That y-intercept is the -5. So remember, the number by itself is the y-intercept. So side is where we're going to start. And the slope is 2. So remember, if it's a whole number, pretend like it's over 1. So we're going to move up 2, right 1. In order to grab more points, we can also go the opposite direction. So we can go down 2 and left 1 to create more points. So let's go ahead and start this line. Again, I'm going to use an oval shape to make some points. And this one is going to start -5 down here. So there's my first little circle. Click off of that so it stays. The next one, if I move up 2 and right 1, up 2, right 1, my next point would be at this 1, -3. So there, click off of it so it stays, and go up 2 and right 1 again, 2, -1 is a point, and the next one, up 2, right 1, notice this is where it's going to put the absolute value. This is kind of what we're looking for. So I'm going to make sure that point is there. Click off of that. And then if you want to make 1 or 2 more points just to get a good idea of where this graph is going to go, or where this line is going to go, you can do that. Okay, so that should give us enough points to connect those. So now I'm going to choose my line tool. I'm going to start with this original point and connect through my other points. I haven't clicked off of this yet. If you notice there is an end over here, I can actually drag this line a little bit further down just so it extends further. But here is where we can see our two functions or our two equations intersect. And remember, with a system, that's what we're looking for. That's going to tell us where our solutions are. So I'm going to go ahead and choose this little brush option. I think there's kind of like this little marker tool. I'm going to go ahead and mark that spot in a different color. Let's make it green. And that's a really big point. I don't want to see that big. This big. So this is, so I'm just going to put a little dot there. Section spot. Just so we kind of see that's where it is. If you wanted to draw a little arrow to it or something, you can do that too. However you want to express that that's where the solution is. And then somewhere over off to the side here, you would also want to list. So our solution, right? Solution is the point 3, 1. So in parentheses, 3, comma 1. That's the coordinate, and then make sure that it looks like a coordinate. Remember, put it in parentheses, and that's our final answer. Okay, well. Okay, alright, let's make a new answer because apparently the box was not good. Okay, there we go. There's our solution. That's our final answer. We want that point 3, 1 because that's where they intersect. Okay, so you could take this. You could always save it as a file or save it as a picture, and then upload that into the test, like if this were one of your questions. Or again, you could use the little snippet tool, and you could take a picture of the whole problem and save it that way as well, whichever way it works best for you. But that's just another tool you could use if you don't want to use Google Draw. You could always use Paint. So those are kind of the two main computer tools I would suggest using. All right, so we're going to do that again because we do have one more system that we need to graph. So I'm going to actually get rid of this, and I'm not going to save it, but that would be what the answer supposed to look like. And now we got to work with number 4 here. So I'm going to use Paint again. So I'm going to find that application again, open it up, and I'm going to paste this grid into it. Here is grid, and get that function on here, system, make my snipping tool. Oh, let's make it the whole problem. Okay, so there's my problem. I'm going to snip, copy that, over into Paint, paste it. Alright, so this is what I'm going to be graphing. Okay, So to start us off, looking at this top equation, if you notice it has the exponent 3, that's going to tell us what type of function this is. So let's take some notes on what's going on here. Exponent 3 means it's a cubic function. There are two transformations happening, okay, or cubic, so depending on what class you're in, some people will call that a snake, some people call that a bent paperclip. Remember, there's no fancy name for that one, you just kind of have to go with what you think it looks like, but mainly it's the one that's going to stretch up and down through your graph, so kind of keep that in mind. There are two transformations happening, so this one is also flipping, so I'll show you how to make sure that it looks flipped. And then the second transformation is that plus 2. So remember, plus 2, it is after the exponent, so that means it's up, shift up 2. Okay, so that's what it's going to look like. Let's make this one, let's make it purple. Okay, so I'm going to go ahead and start graphing. I'm going to choose my oval tool because I need to make some points. All right, so this one, remember, pretty much all of our functions start at 0, 0. But because this is going to shift up 2, I don't want to create it at 0, 0. I'm going to move up 2 first and create my original point, or my first point at this 0, 2. So there is my very first point. I'm going to click off of it so you can see that that's where it is. Okay. So from here, the other points that would end up on our cubic, you would have the point 1, 1. You would also have the point 2, 8. Some other points we would have -1, -1, and we would have -2, -8. So keep in mind, I don't want to use those original points. I want all of them to move up 2. So we also, well actually, so we would move them up 2. We're also going to flip them, which means that if they originally went up, we want them to go down. If they originally go down, we want them to go up. So it's going to look a little weird here. I'm going to start off with the point that would end up at 1, 1. So if we have this 1, 1 point, I'm going to move it up 2. Okay. Now keep in mind, this isn't moving up anymore. In relationship to this original point, the 0, 2 point, we want it to go down from there. So if it would be up 1 and over 1, we're going to move down 1 and right 1. Here's going to be that new point, which is going to look a little weird, like I said, but it's doing the flip for us. Okay. That second point would be at 2, 8, but we would have to move up 2, and that's almost off the graph, but that's okay, because technically this one's going to shift down instead. Originally, if I were to count to my original point, this would be 10 away, because it's at the point 2, 10. So for this one, I want it to be 10 away from this point, so I'm going to move to the right 2 and move down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it, yeah, that is where it should be. It should, wait. I feel like I've gone too far. Hold on. Okay. Oh, technically, okay. We don't want it to be that far away. Sorry. It would be at this 2, -6. We would want it to be there. Okay. Sorry. I knew that was too far away. This is where the flip and the shift gets a little confusing. But trust me, that's where it would end up. Okay, so that is the right side of my bent paper clip for my snake. Now I gotta do the left side. So from here, we're just gonna kind of mirror this, but it's gonna go up on the other side. Typically there would be a point at -1, -1, but we want that one to be above my starting point now, so it's gonna be at -1, -1, +3, so that's gonna be my next point. And then my next point from there, if I were to go over it now, 1, 2, 3, 4, 5, 6, 7. Okay, so it's barely going to fit here. But this point would technically be at negative 210, and that is our flipped bent paperclip that it shifted up to. Like I said, I know it looks crazy, but that's what it's going to look like. For this one, so you can try to use your curve tool or your curve line if you want to try to connect them and it be smooth. You can also just use like a pencil tool or something and try to connect the lines or try to connect the dots into some kind of shape. The main thing there is that we make sure the points are in the right place, which the points are in the right place, so we're ready to connect them. Actually, I don't trust myself with this curve tool. I'm going to use the pencil tool instead. So I'm going to start here at this top one. I'm just going to drag it down and over through the other points and then down to the very bottom. And yeah, is that pretty? Not really, but that's okay. Like I said, it's more important that we understand where those points are, but that's kind of what it would look like. Okay, so now, ready for the second function. So the second function, if you notice, it has a square root symbol. So this is the square root function. Let's take some notes here. Let's make this one 1. So this is square root, which, depending on what class you're in, you either call that a curvy ray or curve to the right. Either one of those, because that's what it should look like. This one also has 2 transformations. So if you notice, it has the +3 underneath the square root. So that +3 actually means that it's moving to the left 3. So 3. And this -1 on the outside, remember outside is up and down movements. This is going to shift down 1. So that's where we want our points to move. Now keep in mind this is still a curve to the right. All of our points will be kind of moving over here to the right side. The main thing is that we want to make sure they end up in the right spot. Okay, so typically for the square root function, we only have 4 points. We only have the point 0, 0, 1, 1, 4, 2, and 9, 3. But keep in mind, we don't want them to end up at those original points. We want them all to shift left 3 and down 1. So I'm going to make some circle points here. So instead of 0, 0, if I move left 3 and down 1, that means my original point or my starting point for this curve to the right is going to end up at -3, -1. So I'm going to graph a little circle there and click off of it so it stays. My next point, if it were at 1, 1, remember we don't want to actually put it there. We want to go to the left 3 and down 1. This one's going to end up at -2, 0. A little point there. Okay. The next one would be at 4, 2, but if I move to the left 3 and I move down 1, okay, so this is kind of overlapping this 1, 1 point on my bent paper clip, which is a good sign. That means that there is at least one solution that we're going to have. Okay. And then my next point that would be on my curve to the right would be this 9, 3, but if I move left 3 and I move down 1, this next point is at 6, 2. Okay. So those are all the points that exist on our square root function. So from here, I'm just going to connect these. Again, I'm going to connect it with this little pencil tool. I'm going to try to make it a little thicker this time, though, since that one was a little thin. But remember, it does not go past the original point. So from this original point, I'm going to take them and I'm going to connect them over to the right. I can make an arrow on the end. And that's the only direction it'll go. So, let's see. Okay. But here is our system. Okay, so they did overlap. They ended up overlapping at the point 1, 1. So again, I'm going to kind of highlight that point. Let's see here. Let's choose a different color. Let's make it pink. And I can kind of just draw around that point in the pink. And I'm going to make a little note over here about it, like this is going to be our solution. So our solution is the point 1, 1, so 1, 1. Use your parentheses, it is a point. But there you go. That would be our final answer. So again, you can copy and paste this. You should be able to save this file as like a JPEG or as a picture, and you'll be able to upload it that way too. but that's what we would have. So here is our last system. Um, if you have any questions about any of these tools that I've shared with you, please let me know. But I feel like as far as graphing on the computer, either using Paint or using the Google Draw, those are going to probably be your best bets. So for the rest of this review, if I scroll down, the rest of the review, we're working on these graphs, like trying to read these graphs. So thankfully we don't need Paint or Google Draw for that. We can just kind of type things in. The main thing here is that you do want to make sure you're using the right symbols. So if you if your keyboard's a little limited, um, you know, I understand. You'll probably have to make a note of that to me. Or if you can like write out in words what you're trying to describe to me or what you're trying to tell me, you can also do that. Basically, just do the best you can. So what we're going to do, zoom out a little bit so we can see more of this. All right, so let's run through the information on this first graph. So the first thing they want is domain and range. So remember, domain, that is talking about all the x's on your graph. You don't want to list them out. You want to write them as an interval. So you find the first x, okay, well, x's go from left to right, so we start on the far left, and our first x is this -10. Okay, so that's going to be the start of my domain. If I go all the way to the other side, over to the right-hand side, this stops at +10. Okay, so from -10 to +10, that's where my domain is. So I'm going to use some interval notation here. I'm going to get rid of part of this line. Okay, so if you want to use the correct symbols and you're using Word document or Google Docs or something like that, you should be able to insert an equation. Okay, so I'm going to insert my equation here. And then now I have options to use the different symbols. So I can have like a less than, or I can have a less than or equal to, depending on what type of information I need. So the domain, remember, domain always uses the less than or equal to sign. So I have to use this less than or equal to sign. But I need to type in that -10 first. So I'm going to type in -10. And then I'm going to click on my little less than or equal to sign. So it inputs that here for me. X goes in the middle. Since we're talking about x's, I need another less than or equal to sign. Remember, there should always be 2. And then I'm going to end with this +10. So that is the domain for this graph over here on the right. That's how it would have to look. -10, less than or equal to x, less than or equal to 10. Okay. The next thing is range. So remember, range, you're talking about y's, and you want the lowest point to the highest point. So the lowest is this -4. It's the only time we use the y value. So we'll use the second number, and then we go all the way up to the highest point, which the highest point here is at 10. So my range is going to be -4 all the way up to 10. So again, I'm going to use my, let me get rid of some stuff so it's not so long. And I'm going to insert another equation so I can use the proper symbols. So this time I want to start it at -4. -4 less than or equal to. Remember, this is the only time we put y in the middle because we're talking about range, and range is talking about y's. So y goes in the middle, another less than or equal to sign, and then the +10, talking about the topmost point. Okay, so those are my domain and range. Okay. The next thing they want to know, find f of -2. Remember, if they ask you f of a number, they want the y that goes with this x. So I'm going to find -2 on my graph. Okay, so if I go over to -2, my point is up here, and the point that goes, or the y, that value that goes with that x is 6. So all I have to do is type in the 6. There we go. F of 2 equals 6. F of 7, they want to know if it's positive or negative. So again, you just have to tell me one or the other. So I'm going to go find that x value on my graph. So if I were to go over to the +7, if you notice, there's no point at the +7, but in order to reach my graph, or this function, I had to move up in order to touch the line. So if I had to move up, that means that this point is positive. It is above the x-axis. So I'm going to type that in if this was a positive point. All right, that was a positive point. It was above the x-axis. Okay, next part. Where is f of x positive? All right, so we're looking on our graph. What parts of the graph are above the x-axis? So here's my x-axis, this horizontal line. I need the interval, or the whole portion of the graph that is above this. Okay, so if I look right here, starting over here on the left, this is not above the x-axis. I got to go to a point that is. It technically starts at -5, 0, because this point hits the x-axis, and everything from that point on is above. I don't ever dip below again. So my interval that I'm going to say, because I don't want to list all these out, I want to use an interval. I'm going to say from -5 all the way to this +10, this is all positive. Okay, so I'm going to use my little equation tool. My equation. Okay. So it starts at -5, but here's the thing. This -5 value, okay, this is where you kind of have to pay attention. It is not a positive point. Remember, -5 goes with 0. 0 is not a positive number, and it's not a negative number. It's like this weird neutral middle zone kind of number. So we don't want to use the less than or equal to sign with the -5 because it is on the x-axis. What I'm going to do instead is I'm going to use the strict less than, the one that doesn't have a line under it, and that's going to be used next to my -5. So if I scroll down, see how I type that in, -5 less than. Okay, I'm going to put x in the middle because I'm only using x numbers. And then I'm going to go back to my graph to look at +10. So +10 is over here on over on the right, and it is way, way, way above my x-axis. So if I look up here, it does go with a positive number. I want to use the less than or equal to symbol before I type in that 10. So when I scroll back down, okay, so here's my function, my little cursor is waiting. I'm going to use the less than or equal to sign, and then I'm going to type in my 10, and that's my interval saying that this portion of the graph is positive. It started at -5 on the x-axis, and it went all the way up to 10, and that is for sure positive. Okay, so there's the positive part of my graph. We got to do the same thing for the negative part of the graph. So we're looking for where the graph is below the x-axis. So this graph is below the x-axis, and this little portion right here, it starts at -10, and it goes over to this -5. Like this little dip right here is the negative part. Both of those points, if you notice, they're both on the x-axis. So we can't necessarily include them. We can't use the less than or equal to signs here. We have to use the less than, just like we did before with the -5. So to type in, I'm going to insert an equation. And I'm going to start with -10. And I'm going to use the less than sign without the line, x, another less than sign without the line, and then to the -5, because that was the whole part that was below. And there is my negative portion of the graph. The next thing I want is, where is the graph increasing? So if you remember what increasing means, that means where is the graph going uphill? So if I look, there's actually a couple different places. There is this section right here from -8. I know this is +8, but this is a -8, right? That's where it is. Whoever made this made a typo. So it starts at -8 and it goes all the way up to -2. Okay, so this is one increasing part of the graph. There's another increasing part right here. So it starts at 0 and it goes up to 2. That's another increasing part. And then there's this third increasing part that goes from 5 to 10. So I'm going to show you how to type all those in. There are 3 different parts of the graph that go uphill, so we have 3 different intervals to type in. Okay. So where is this increasing? I'm only going to type one interval right here. And type the other 2 words. So I'm going to insert an equation. Okay, so that first interval, like I said, It started at -8 and went up to -2. So I'm going to type in -8. Increasing and decreasing. We only ever use the less than symbols. We never use the one with the line underneath it. So I'm going to go ahead and use this less than symbol. Type X in the middle, another less than symbol, and then type my -2 after that. Okay, so that's the first part that goes uphill. There are two other ones though, so I'm going to get rid of this line to continue the answer. Insert my next interval. So the next one started at 0. So I'm going to type in 0, use the less than with no line underneath it, an X, and then another less than the 2. Okay, so that's my second interval. And then there is one more. My third interval went from 5 to 10. So I'm going to type in 5, use my less than symbol, X, less than symbol, and with 10. Okay, so those are the three portions. So here's the first portion, here's the second portion, here's the third portion. All three of those go uphill. Two more things they want to know. They want to know the local maximums. Okay, so remember maximums, they have to be at the top of a hill. They cannot be endpoints. In this graph, if I were to follow along, there is this point right here, -2, 6, that's at the top of the hill. And this point 210, that is also at the top of the hill. So we technically have two maximums, and that's okay. We can have however many the graph gives us. So I want to list both of those points. We are talking about just the points themselves being, the top of hill points. So if I go down here, I'm going to type in, and it is a point, and you need to use parentheses. So I'm going to say parentheses, -2, comma 6. Close parentheses, that is the first one. And then the second one was the point 210. So another parenthesis, 2, comma, 10, close my parenthesis. There's my 2 points, 226 and 210. Last but not least, they're looking for the y-intercept. So remember, y-intercept, there should only ever be one of those. In this particular graph, if I look for the point that intercepts the y-axis, it is this 0, 1 right here. Okay, so that's the point that I need to list. And then I'll be done with this one. So I'm going to list 0, 1. And there is all the information that I needed for that very first graph. So remember, kind of look through 10.1 and 10.2 notes to talk about those, or past reviews that talk about that stuff. That is kind of going through and giving a little bit of everything. Okay, graph number 2, we're doing very similar things. So I'm just going to go through it a little bit quicker, just so you guys have the answers for that as far as what it's supposed to look like. So very first thing they want to know, domain. So again, you want the farthest left to the farthest right. So this goes from -8 all the way over to +10. So use my equations again, because I need the less than or equal to symbol. So start with -8, less than or equal to x, less than or equal to 10. There's our domain from left to right. Range, you're using the y values, and you're going from the lowest to the highest. Well, technically, the two lowest points are with this -4, so it doesn't really matter which one you focus on, because both y values are -4. So I'm going to start with -4. The highest y value is this 5. So from -4 to 5, that's our range. And so I'm going to insert equation. So -4 less than or equal to y less than or equal to 5. Remember, y is the only time we use that in the middle is with range. But there's our range. Okay. This next part, find f of 5. So remember, I'm looking for the y value that goes with that x. So if I go over to 5 and I find my point, 1 is the y value, so I need to say this equals 1. That's all I have to do there. Then they want to know is f of negative 3 positive or negative? So if I go to my graph and I find where x is negative 3, in order for me to reach my function, I'd have to go down. So there's not a point here, but I'd have to go in the down direction to meet my graph. So since it is down, it's below the x-axis. That is a negative point. Negative. Where is f of x positive? All right, so again, I'm looking for where it's above the x-axis. So this one starts above the x-axis at this negative 1 on the x-axis, and it goes all the way over to 10. So negative 1, since it is on the x-axis, it gets no line underneath it. So we're going to start. So it's going to start negative 1. I need the less than symbol, x, and then that 10 is above the x-axis. So I'm going to use the less than or equal to symbol, and then the 10, and then get rid of this line so hopefully it all matches up. There we go. There it is. So there's where the graph is positive. The graph is negative. Okay, so this whole portion is below the x-axis. So it starts at negative 8, and it goes over to negative 1. So I'm going to type this in. So it starts negative 8. Since that's below the x-axis, I get to use the less than or equal to symbol. X goes in the middle, and then that negative 1, again, it was on the line. It gets a no line underneath, so I go to the less than symbol, and then I type in negative 1 again. Where is f of x increasing? So where does this thing go uphill? Well, if I look to see where it goes uphill, there's only this one little portion. It goes from negative 4 all the way to 2. That is an uphill slope. So negative 4. So negative 4. Remember, this is a strict less than. We only use the less than symbol, x, and then less than 2. 2 was at the top of that hill. So that's where it stopped. Okay, decreasing. So where's the graph going downhill? And if I look to see where the graph is going downhill, again, there's only one portion that goes downhill. It's from 2 to 5. So from this point up here to this point down here. So I'm going to list this out. So 2 less than x less than 5. There we go. So that's all typed in. So that is where it decreases or goes downhill. Next, they want the x-intercept. So remember, there can be more than one x-intercept. You're just looking for where the graph crossed the x-axis. In this case, there's only one. It is this point right here, this negative 1, 0. So I'm going to list that point. Okay, so negative 1, 0. That is the x-intercept. They also want to know about maximums and minimums. Remember, maximum has to be at the top of a hill. And if I look right here, there's only one point that's at the top of the hill. It is this 2, 5 point. I'm going to go through 2, 5. Okay. So 2, 5, that is the local maximum point. And then it also asks for local minimums. Okay. So minimums have to be at the bottom of a valley, meaning it has to change from decreasing to increasing. And if I look right here, this little piece of my graph was constant, okay? I can't say that this is a minimum value because it's not at the bottom of a valley. Same thing with this 5, 1. It was decreasing, but it didn't turn to increasing. It went constant again. So that is also not a minimum. So this graph technically has no minimum values. So if I want to give an answer here, I can just say that there are none. I can say that it's not available. I can say it does not exist. Whatever you want to type in here to tell me that there aren't any, you would, whatever you would put there. But there aren't any local minimums. So that's kind of a recap of graph 2. And technically, we've made it all the way through the review now. So if I go back to our little meeting here. Okay, so that takes care of everything. Hopefully, that gives some better explanations. I know that took a while, and I know it's going to take a while to get through assignments and different things, and I totally understand. Um, I don't love this either. I would much rather be at school with you guys. Um, but yeah, we're just going to try to get through it the best we can. If you have questions, please, please, please come to my Google Hangouts. Hardly anybody has showed up, and I kind of feel unloved. So if you want to just come in and say hi, you can always do that too. But yeah, or send me an email, send me a message on It's Learning, whatever you want to do to communicate with me, that's totally fine. So hopefully, like I said, that helps. And good luck with everything. Make sure you're getting caught up on all the work. I'll take that through spring break, and let's be honest, we're supposed to be inside and not hanging out with people over spring break. So hopefully you have time to get that done. All right. So I'll talk to you guys later. Love you. Bye.